All right, we are finishing up the second part of 2.2 notes, okay, normal probability plots. All right, so here we go. So the question is, how do we know if the distribution is normal, okay? So we definitely know that we shouldn't have outliers. It needs to be roughly symmetric. It needs to be unimodal. So there are ways of us being able to tell if a distribution is normal, if they give us data. We could look at a box plot. Are y'all here? Is this where everybody's at? Are y'all good? Okay. All right. So we could look at a box plot to see if it's roughly symmetric with no outliers. Okay. We could look at a histogram, but histograms are, it's hard on our minds because we're like, is that an outlier? Is it kind of skewed, and we fool ourselves, a lot on that. And so histograms are probably the worst way. And that's why we've created these density curves that have area underneath it of 1, right? And that gives us a better idea of if something is approximately normal or not, okay? But there's another way, and this is called the normal probability plot, okay? It is a plot that your graphing calculator is going to do, and it is going to base the x-axis is going to be the x-axis of whatever you're talking about, the proportion of yellow M&Ms, the height of females, whatever that x-axis is. And then on the y-axis, it's your z-scores for every single dot, for every single observation. Okay, you'll have a z-score. So some of them should be negative. You hit 0. Some of them are right on the mean, and then some of them should be positive. Okay, and they should go on so on and so forth. And of course, you kind of put them in order in your mind because the negative numbers. Think about a distribution or a normal distribution curve. All of these over here are negative, negative, negative. You hit the mean. That's 0. Positive, positive, positive. Right. So where should the bulk of them be? Right around -1 to +1, right? 68%. So we're going to look at this normal this normal probability plot. We'll have a few down here, and then you'll see lots of dots, lots of dots. It's going to look like a scatter plot. And then you'll see a few here, and it should be that way where you see a concentration towards -1 to +1. If it ends up being linear, then that means that it does follow a normal distribution, okay? So systematic deviations from the straight line, okay, indicate a non-normal distribution. Outliers may appear to be very, very far away. So we will look, and again, could an outlier, I call them unusual points, but could an outlier be a part of a normal distribution? Like you have this curve. Could it be like really far down there and really far down there and it's still following under the curve? Yeah, so you can have some outliers in that, but you're not going to have like 5 outliers over here and none over here because then that might start causing it to skew. Okay, so we're going to look at some normal probability plots. So here we go. All right, we're going to look at a few and we will do one as well. Go. All right, so this is what we're going to do. We're going to put data in list 1. We're going to look at our 5-number summary because you always want to see if the mean and the median are about the same, right? So we can go to StatCalc, 1 variable stats. Then we can also do a plot, and I will show you how to do all that. So let's do an example here. All right, so turn to page 156 in your book. It's example 2.40. Let me see if I can find the book. Hopefully we'll have some new books coming up really soon. All right, I do have to find my book. All right, example 2.40. And we're going to look at it and we'll do it together. I'm just going to hover over one of y'all. All right, so input that data. And then we'll do the normal probability plot together. What are we doing? The density of the Stat calc, one variable stats. That would, like, if you put a frequency of something else, it would count it more than once. Okay, I need to know what the same answers. So, type fast. I'll put it to see you at 25 more seconds. Hey, there we go. Okay. All right, I got an X bar of 5.4479. So stat calc, one variable stats. See if you got what I got.